Hell yeah, thank you.
Frick yeah.
What? There it is. What this 1.6 means is, on average, here it is again, damn on average, just like 105. On average, except not over time, just on average. On average, the data will be about 1.6 points away from X bar. That's what it means. What it gives you is it gives you an approximate average value of the deviation of the data from the mean. That's all it does. It takes a lot of annoying math to get there, but that's all it does. Ask me that question, Eric. Are you phrasing the question or are you just taking it in right now? I'm trying to read your face.
I'm just
You're processing.
Yeah.
I'm sorry, I jumped in there too soon. Keep processing, my friend. Keep processing. Ask me questions if you have them right now. Please, let it go. Yes?
Why isn't it just 1.5? I mean, these values are pretty clear-cut.
No. I agree. Why isn't it 1.2? 1.2 seemed so logical earlier. We were actually doing the same thing then, weren't we? 2, 1, 0, 1, 2, divide by 5, 1.2. Because they're not exactly the same, because of the squaring and then square rooting, something happened between that, right? Didn't something happen between those two things? We divided by this linear measure. That screwed up the beautiful symmetry a little bit. Kind of annoying, but that's okay. We can live with that. So the idea is, it won't exactly mathematically make perfect precision sense on the data set. We're trying to apply this to the overarching population, which you'll never see. So that offness is that factor I talked to you about the correction for bias. So that's why I don't ever want you guys to get lost in that calculation. How many of you had enough about right about here? You were like, yeah, this is enough. You told me there wasn't a whole lot of math in this class. Good. I wanted you to have enough right there because I want technology to do that calculation for us. And what I want you to be able to do is to tell me what it means when all is said and done. Question number 2 or 3 on your exam, I forget what it is. You analyze the laying habits of my chicken flock. And at some point in there, I have you use Excel to calculate the standard deviation of my egg-laying chickens. And then I asked you, what does that mean? Exactly, thrilling. And then you tell me, what does it mean when they have a standard deviation of, I don't know, whatever, 3 eggs? What does it mean to have that standard deviation? You just apply that statement to the new data. Boom, that's it. Does that answer your question satisfactorily? It's not going to be perfect, I know, Linda. I know it's not going to be perfect. But satisfactorily. The reason why it's not fitting perfectly is, and this goes back to Tom's question about the population versus the sample. There is a slight difference in how you calculate the population variance and population standard deviation. You actually divide by everything. But that's fiction because you never have everything. That's why I focus on this one. Katie, go!
Oh my gosh. So.
I'm excited. This is good stuff.
ADD.
It's okay.
Shiny scrolls. On average, data will be blank points away from X or
X bar. That's X bar, right?
X
That's
bar.
the sample average.
That's the definition of
That's the interpretation of sample standard deviation,
Okay.
right? That's how I want you to interpret it.
SSB.
Yep, exactly. And that little 1.6 will vary with the data set. Will Bert's be bigger or smaller?
Bigger.
Bigger? What do you think it's going to be? Guess. You don't want to? Okay. Okay, then let's not. I'm sorry, Eric, I didn't mean to upset you. Grab your TIs, grab your machines. Let's show you how to calculate this thing using technology. Yeah. Now, Excel, on your exam, I teach you how to use Excel to do this. Not everybody has Excel in their hands right now. So we'll use the TI in class, but you'll have Excel on the exam. We'll teach you how to use Excel, because Excel is definitely the way better way of doing this. But for in class, rough and ready,